picture this, right? It is like 2 a.m. on Black Friday.
Oh, the absolute worst time for anything to happen.
Literally the worst. So the marketing team of this massive Fortune 500 retailer, they are just panicking because their marquee holiday campaign just went live, but the homepage is completely blank.
Wow. Just totally blank.
Just blank, like it's not even throwing an error code, just a white screen. So engineering scrambles, they're diving into the server logs, they are totally convinced it's this massive database failure or, I don't know, a CDN outage.
Right, because that's what it usually looks like.
Exactly. But 3 hours later, they finally find the culprit. And get this, a junior content editor was just trying to make the holiday banner text like a little bit bolder, and they accidentally deleted a single closing div tag inside the monolithic CMS's rich text editor.
Oh no, a single div tag.
Yeah, because the content, the presentation, and the underlying code were all just, tightly woven together into this massive, fragile knot. So a simple typo took down an entire enterprise architecture during literally the most critical revenue event of the year.
Yeah, I mean, that is the ultimate digital nightmare.
Yeah.
And unfortunately, in the era of those old monolithic systems, it was an incredibly common one.
It really was.
Because when your content and your code are sharing the exact same breathing room, a failure in one basically guarantees a failure in the other.
Right, exactly. So, it's stepping into the absolute definition of diagnostic muddy waters. You aren't just dealing with code bugs, you are dealing with content bugs that are masquerading as structural failures.
Which is so hard to untangle.
It's impossible. And this is exactly why the industry has just aggressively pivoted toward headless architecture. But here's the catch, right? Ripping the head off your CMS doesn't automatically solve the problem.
No, it definitely doesn't.
If you decouple your front end from your back end, but you don't actually take the time to meticulously engineer your data structures, you haven't solved the spaghetti problem. You've just, moved the spaghetti to a completely different bowl.
Pretty nicely.
Yeah.
You've basically just created an API that serves chaos.
Yes, an API that serves chaos. I love that. Okay, let's unpack this. Welcome to today's deep dive, everyone. Our mission today is to shortcut your journey to becoming a headless CMS architect.
And that's a journey everyone in digital infrastructure needs to be on right now.
Totally. Whether you are prepping for a massive enterprise website redesign or you're just, insanely curious about modern digital infrastructure, this deep dive is going to give you the ultimate toolkit. We are focusing purely on the foundational philosophy and the practical application of content modeling using Contentstack.
Because honestly, content modeling isn't just some preliminary step. It really is the unseen backbone of the entire modern web.
Right. And for you listening, this is why you should care. Without a proper content model, you end up with unmanageable, unscalable data lakes. Your front-end applications crash because they receive like a text string when they expected a Boolean. Mastering this process empowers you to bridge that massive gap between technical developers and creative content marketers. So let's establish the ground rules here. What does content modeling actually entail at a granular level?
Well, at its core, it's the process of structuring and organizing content into stripped, predictable schemas.
Like a database.
Very much like that. If you have a background in back-end engineering, it functions very similarly to relational database design. We are defining exactly what data types are allowed, how they relate to each other, and what the ultimate JSON payload delivered by the API is actually going to look like.
Let's really hammer home the profound architectural difference here between the old monolithic way and the headless paradigm. Because in the old days, the text, the images, the layout, they were practically welded together, right?
Right. You were effectively storing raw HTML strings right in a database.
Which is wild to think about now. If the design changed, you had to physically migrate the text into new HTML templates. Building a digital platform without a content model, it's like building a custom home without a blueprint. You might end up with the bathtub in the kitchen and no stairs to the second floor.
That's a great analogy. And if we connect this to the bigger picture, this granular modeling is exactly what future-proofs an organization.
How so?
Because the content lives completely isolated from the design layer. It's stored as raw, structured data. So the exact same text and images can be seamlessly delivered to a website, a mobile app, or, even a smart refrigerator. The CMS is totally blind to the destination.
It just doesn't care.
Exactly. It only cares that the data adheres to the strict schema you built. That's why analyzing wireframes and site designs before you touch the CMS is a crucial best practice.
Right, you don't just look at a wireframe and say, okay, we need a homepage. You deconstruct it. You ask, what discrete fields do we actually need here? Because if you just wing it, you are guaranteeing tech debt. Inconsistent formatting, duplicated efforts, poor SEO.
Data integrity issues everywhere.
Oh, everywhere. And this nightmare of difficult future updates. So if we accept that the model is our structural blueprint, we need to examine the raw building materials we use to construct it.
Which brings us to the core structures of the headless architecture. We're talking about the Holy Trinity here: content types, entries, and assets.
Let's break those down for everyone.
Sure. Content types are the schemas, right? They are the strict JSON blueprints. Entries are the actual instances of data, the specific payloads you create from those blueprints. And assets are your digital media, like your images, PDFs, video files.
Now, when an architect sits down to design a content type, they immediately hit this crucial strategic divergence. They have to decide between a single content type and a multiple content type.
And that choice dictates the routing and the fetching logic entirely.
Let's use an example.
Okay, think about an e-commerce site. A product detail page is a multiple content type. It's a collection. You might have 10,000 products, but they all adhere to the exact same schema: product name, description, price, image gallery.
But on the flip side, you have a homepage or an About Us page. These are single content types. They only occur once.
Right, exactly.
But, okay, I'm going to push back here because I've had this exact argument with front-end engineers. If a single content type, like a homepage, only exists once, why go through the trouble of modeling it in a CMS at all? Why wouldn't a developer just hard-code it into the React component and be done with it?
This raises an important question, and it's a super common engineering pushback. But it completely misses the philosophy of adopting a decoupled system. Hard-coding a singleton locks the marketing team out.
It creates a massive bottleneck.
Exactly. The entire philosophy of Contentstack is to empower non-technical editors to update any part of the site without needing a developer. If the marketing team needs to change the wording in the footer and it's hard-coded, they have to write a Jira ticket.
Right, and wait 2 weeks for a sprint cycle.
An engineer has to update the code, run tests, do a full deployment. You just spent thousands of dollars to change a copyright year. If it's modeled as the single type in the CMS, the editor just updates a text field, hits publish, and it's live instantly.
Okay, yeah, that makes total sense. We put the data in the CMS to democratize access to it. So let's look at how a team actually deconstructs a design to build one of these schemas. The documentation uses a news article as an example.
Right, so you don't just give the editor a giant text box. You determine the exact fields required: a discrete string for the title, an image reference for the main image, a summary block, the body text, the author.
And the order they appear in the interface matters too, right?
Absolutely. The data architecture has to be rigorous, but the authoring interface built on top of it has to be intuitive for the humans actually using it.
Now, once these core structures are built, developers and marketers need a safe sandbox to test them before showing them to the world, because you cannot validate complex data structures on a live production database.
No, that's how you cause a Black Friday catastrophe. You need absolute isolation, which is exactly what publishing environments provide.
Let's talk about that. Contentstack has this really robust feature for environments. You've got development, staging, production.
Right, and these aren't just labels. They are physically isolated destinations for your content.
How does that actually work mechanically?
It all revolves around unique delivery tokens and base URLs. The development environment has its own unique token. Staging has its own token. Production has its own.
So when a front-end engineer is working locally, they just use the development token.
Exactly. And the API will only return content that has been explicitly published to the development environment. The live website is completely blind to it.
That is so cool. And Contentstack takes it a step further with environment branches, right?
Yes. Branches are critical for parallel workflows. Say you have a team redesigning the entire website taxonomy and another team just doing daily blog posts.
If they're in the same environment, they're going to step all over each other.
Precisely. Branching lets you clone the content model. Team A can make radical changes in their branch, test them, and then carefully merge them back without ever disrupting Team B's day-to-day operations.
I can see that being huge for like localized content testing or onboarding new employees safely. You just spin up a sandbox and let them play. But practically speaking, with all these different environments, dev, staging, prod, isn't it a massive headache to keep track of what content lives where? Do things ever fall out of sync?
Oh, absolutely. That's the classic content overlap problem. When you distribute data across environments, Synchronization challenges are just inevitable.
So how do you fix it when someone messes up?
Well, Contentstack has integrated workflows and strict versioning systems. Every time an entry is saved, it scores an immutable snapshot. So if an old version in staging accidentally overwrites production, you can instantly audit the log and trigger a built-in rollback to fix the data consistency.
Okay, so we've got our safe testing ground. Now it's time to dive into the exact fields we place inside those core structures to capture data. Let's start with the foundational building blocks: Boolean, date, file, and number fields.
They sound simple, but they are the absolute bedrock of a stable API.
Here's where it gets really interesting, because I think of these fields like a highly disciplined filing cabinet. It physically prevents you from putting a text document into a folder meant strictly for numbers.
And that strict data validation is critical. Let's take the Boolean field. It's a simple toggle switch, true or false.
Right.
In the news article example, a Boolean becomes your featured article toggle. If the front end expects a Boolean to trigger a specific layout and the CMS allowed an editor to just type the word yes,
the front end receives a string instead of a Boolean, the condition fails, and the layout breaks.
or worse, the whole application crashes. The same goes for date fields. They handle strict ISO 8601 formatting. The editor uses a nice calendar UI, but the API delivers a precise, time-sensitive string that the front end can parse flawlessly without time zone nightmares.
And the number field. If an editor accidentally typed the word 20 into a price field instead of the actual number 20, and the front end tries to calculate a 10% tax,
It returns, not a number, and the checkout cart crashes. The number field allows for safe mathematical operations and sorting.
and then there's the file field, which handles remote assets and CDN integration, like the main image of our article. So these fundamental fields handle standalone data beautifully. But a CMS becomes truly powerful when pieces of content start talking to one another.
Which brings us to reference fields. This is how we establish interconnected relationships between different content types.
And this is all about avoiding duplicated work, right?
Entirely. It enables massive content reuse and strict consistency. You have self-referencing, like related products within an e-commerce store that point to other products.
And then include referencing, which I think is more common, like a blog post referencing a separate author profile.
Exactly. And the huge advantage here is the cascading update. Let's say an author changes their profile picture or updates their bio in their unique author entry.
Because you used a reference field, that change automatically propagates to every single blog post they have ever written. You don't have to manually update 50 articles.
Right. It's instant global consistency.
Okay, but cascading updates sound like magic. What if you don't want an update to change older posts? Are there dangers to referencing?
Oh, absolutely. There are definitely obstacles mentioned in the text. The biggest one is performance impacts.
Like slower load times.
Yes. If you have deeply nested references, fetching all that data can cause severe latency. There's also the danger of unintended cascading errors and just the steep learning curve for content editors trying to visualize this complex web of dependencies.
Yeah, if an editor deletes a core policy page without realizing 50 products are referencing it, things break. So if reference fields are sometimes too heavy or complex for a simple choice, we need a lighter weight option to restrict editor input.
And that is exactly what select fields are for. They restrict content creators to a predefined list of options.
Like drop-down menus or multiple choice lists.
Right. They enforce a controlled vocabulary. And this significantly reduces human error, like typos and misspellings.
Which is huge for data quality. If you let people type event types manually, someone types webinar, someone else types webnar without the I, and then back-end reporting and analytics just become a total mess.
Exactly. Select fields ensure pristine data for back-end reporting and SEO. You use them for categorizing products, assigning author roles, choosing languages for translation.
But practically speaking, I have to ask you this. When should a developer use a select field dropdown instead of a reference field? Because I could make a select field with a list of authors.
That's a great structural question. The best practice is this. Select fields are ideal for simple static taxonomies, like sizing, small, medium, large.
Because large doesn't have a profile picture.
Exactly. Whereas reference fields should be used for rich, independent entities that have their own metadata. A supplier needs a reference field because a supplier has an address, a logo, and contact info.
Taxonomy versus entity. That's a great rule of thumb. So select fields offer ultimate restriction, but sometimes creators need the exact opposite. They need an open canvas for long-form content.
Which the HTML-rich text editor, or RTE field. It gives creators the freedom to format text add bolding, and embed multimedia elements.
But I always compare the RTE field to giving an editor a free draw tool in a coloring book. It can yield an absolute masterpiece, but if they draw outside the lines, it ruins the entire layout.
It is definitely a balance between immense flexibility and inherent risks. An open HTML field introduces the danger of formatting discrepancies across different devices.
Oh, definitely. Someone pastes in a table from Microsoft Word with hard-coded width.
And suddenly your mobile site is broken. That's why there's a specific need for content governance and user training when deploying RTE fields. Untrained editors might break design systems or even introduce cross-site scripting security risks.
XSS attacks are no joke, so how do developers mitigate that?
They heavily restrict what tags are allowed in the RTE. They might strip out script tags or inline styles, establishing a compromise between editor freedom and front-end stability.
And moving towards abstract syntax trees, or ASTs, instead of raw HTML payloads, right?
Yes, ASTs are huge for security. The API delivers JSON representing the text nodes instead of raw HTML strings,
Which lets the front-end developer render it safely with their own components. So to give editors layout control without the chaos of raw HTML, Contentstack provides a way to bundle strict fields together. Let's talk about group fields.
Group fields are fantastic. They allow developers to bundle related fields together into a cohesive component.
So it offers encapsulation and layout control.
Right, it keeps the CMS interface clean and ensures data consistency by forcing editors to fill out a complete set of data rather than orphan fields.
The documentation gives the example of a navigation menu item. You group a title text field and a URL text field together. Or an image carousel grouping a title, image, and URL for each slide. But is a group field just a visual trick to make the editor screen look prettier, or does it actually change the underlying data architecture?
What's fascinating here is that it fundamentally nests the JSON data structure.
Oh, okay.
It's not just visual. It makes the developer's life significantly easier when writing front-end code because the related data arrives in a single predictable package, like an array of slide objects.
Instead of a messy, flat list of keys. That makes so much sense. But I'm pondering what happens when even these grouped fields aren't enough to capture a highly specific, complex business need. Like, what if you need to pull data from a third-party platform?
That's where custom fields come into play. They allow organizations to enhance the CMS by installing apps via the Contentstack marketplace or even building bespoke functionality.
This is all about workflow optimization, right? Preventing context switching.
Absolutely. Editors don't have to open a new tab to find a product ID in Shopify or grab an image URL from Cloudinary. They can access those platforms directly within the Contentstack entry page.
So, what does this all mean? It's kind of like the App Store on a smartphone. Contentstack provides the operating system, but you can install the exact third-party apps you need to run your unique business logic. The text mentions integrations for Shopify, Cloudinary, BigCommerce, or even utility tools like a custom color picker.
It's exactly like an app store.
Yeah.
But architects have to make a strategic build versus buy decision here. Leveraging the marketplace saves massive development time.
But if you have a proprietary internal database,
Then building a custom field from scratch via the Developer Hub offers unparalleled bespoke control. You can embed your exact business logic right into the UI.
So all the fields we've discussed so far allow us to build these great, strict data structures. But how do we hand those pieces over to marketing so they can actually construct entire dynamic pages on their own?
That is the magic of modular blocks. This is Contentstack's feature for dynamic page building, and it allows organizations to create and manage reusable content elements.
It's essentially a design system of components inside the CMS.
Right. Editors can stack different predefined components, like a hero banner, followed by a text block, followed by an image gallery, to construct dynamic layouts on the fly.
And on the technical side, the front-end implementation is brilliant. In modern frameworks like React or Next.js, developers create a specific component file for each block type.
And then a central render components file just loops through the blocks chosen by the editor and renders them in order.
But wait, if we give editors a box of Lego bricks and let them stack blocks however they want, aren't we risking them building something that looks terrible and completely breaks the brand guidelines?
If we connect this to the bigger picture, modular blocks actually protect the brand.
How so?
Because the developer strictly codes the styling and behavior of each individual block in the front-end framework. The editor only controls the order of the blocks in the CMS, so it guarantees the site always stays on brand and performs perfectly.
The editor gets composition control, but the developer retains execution control. I love that. So we now have this incredibly flexible, scalable, and dynamic architecture. The final step is adapting this brilliant model for the entire world.
Which means we have to talk about languages and localization. Content modeling absolutely must account for a global audience using Contentstack's robust support for multiple languages.
And we have to draw the critical distinction here between mere translation and true localization.
Yes, translation is just swapping English words for French words.
Right.
Localization is much deeper. It's adapting regional preferences like date formats, currency symbols, and even cultural context for images.
By properly modeling for localization, a business can seamlessly deliver highly personalized content on a global scale. But I have a question about the fallback mechanism. To ensure understanding, if I have a page translated into Spanish, but I accidentally forget to translate one specific modular block, does that section of the page just show up blank and break the user experience?
What's fascinating here is that Contentstack's fallback language architecture specifically prevents this.
Oh, really?
Yeah. If the Spanish text is missing, it will automatically serve the master language, say English, for that specific block.
So it serves an English paragraph inside a Spanish page.
Exactly. It ensures the page never breaks, the layout stays intact, and it just highlights the gap for the content team to fix later.
That is unbelievably resilient. Okay, we have covered so much ground today. Let's wrap up this deep dive. We started with the theoretical blueprints of content modeling.
We moved through the isolated testing of publishing environments and versioning.
We dug into the granular application of fundamental fields, reference fields for relationships, select fields for taxonomies. We talked about securing the RTE field and organizing with group and custom fields.
And finally, scaling dynamic layouts with modular blocks and robust localization logic.
It's an incredible journey. And for you, the listener, understanding these concepts truly shortcuts your path to being an invaluable digital architect. You now know how to perfectly balance strict developer control with ultimate creative freedom for editors.
It really is the blueprint for the modern web.
Yeah.
But before we go, I want to leave everyone with a final thought that builds on everything we've talked about regarding these strict content structures.
Let's hear it.
With AI rapidly generating and structuring data everywhere right now, consider this. Will the future of content modeling involve rigid, human-made schemas at all? Or will we soon see dynamic, AI-generated content models that adapt their own fields on the fly based entirely on the user's intent?
Wow. Let that sink in. Thanks for joining us, everyone. We'll see you next time.